Hello and good day, friends. Now I am here with a new video in which I will talk about the ICCP, that is your impressed current cathodic protection. As the name implies, it is the impressed current. ये impress किया हुआ है, अलग से current supply किया जाता है, so that we can make the hull electronegative or cathode and we can protect it. In this diagram, you can see a complete descriptive diagram of a ICCP which is installed on board ship, and some additional thing also, like you have this propeller shaft grounding assembly. This is also going to provide the slip ring and the brushes where the additional current which is generated is being grounded. So this is also one of the protection for the propeller shaft grounding assembly. And ICCP, as you can see, this is ICCP controller unit in ECR. Here you can see the amperes and the voltage display. This is auto regulating unit. DC output is being provided. In this one, you have the reference cell and other anodes, which is basically going to make the complete hull electronegative or in cathodic format, so that this hull will be protected from the corrosion. Here you can see DC output, anode and hull. So it is not only in the aft part of the vessel, we have in the forward also. Forward ICCP, aft ICCP. Here you can see the anodic area. Here we have the sacrificial anodes also fitted in the aft and forward. So that is also one of the method of protecting the ship's hull. You can see here seawater acting as a electrolyte, and anode is there, you can see, and these anodes connected with the power supply unit, and this power supply unit gives the DC supply and make the hull electronegative. So that's how we can protect our ship hull from the corrosion. Now, what exactly the cathodic protection is? In the previous video, we have already seen what exactly the corrosion is and what are the various types of the corrosion and how we can protect the ship's parts, equipments, deck platings and hull from the corrosion part. So this is one of the specific method by which we can protect our ship's hull. Basically, here we have seen when the two electrically connected metals, which is there with the electrolyte or seawater, what happens? The electron will flow. Again, the concept of your galvanic cell formation is there. Okay. So when these two metals are electrically connected, due to the potential difference and presence of the electrolyte, the galvanic cell will form, the flow of electron will happen, and your corrosion current will form. So this is something which is going to complete formation of galvanic cell, and the corrosion process will start. But if we know the potential difference, if we know the cathode, how we can make the part as a cathode, act as a cathode, then we can successfully impress the current and we can reduce the rate of the corrosion up till a large extent. So in this cathodic protection, we are following the same. The current supplied from the anode will gradually dissolve into the ions of the electrolyte. That is what is happening. And the same time it produces the electrons which will establish the corrosion current, and it is received through the metallic connection from the anode. And due to this, what happened? The cathode will be largely negatively polarized and it get protected from the corrosion part. In this one, the surface of the steel plate is not electrically neutral. First of all, we have to understand that. Previously, I have explained you the small pitting corrosions. So where you have the irregularity. But as the steel plate is a alloy, so it is heterogeneous mixture. Or you can see the not uniform structure. So what happens? It is having some electric potential. By the cathodic protection, the steel can be protected against corrosion by supplying the excessive amount of the electrons. But first of all, we have to know how much is required. And it varies also with so many factors. I will discuss those factors in one of the coming slide. So thus not allowing any chemical reaction involving the oxidation. So if we suppress the current, if we supply the current, this will make the hull negative and it will not allow the corrosion to take place. What are the types? There are two types of cathodic protection. First is your sacrificial anodes cathodic protection. We know that we are utilizing on the ship's hull, ballast tanks, as well as inside the equipments also, like the coolers, end plates. We have observed this one basically to safeguard this. So in this process, the metal alloy provide the electrons by sacrificing them itself and then protect the complete structure. Another one is your impressed current cathodic protection that we are going to discuss in this video. It is the process in which the electrons are generated using the electric current. We have the electric current, we generate this one and we impress this one, we supply this one to the hull and make it electronegative and prevent the corrosion part. Cathodic protection is effectively only when the metallic surface is immersed in the electrolyte. So electrolyte is required for the complete protection of it. Impressed current system. What exactly this system is, how it is going to be. So it requires external DC power source. We have to supply that. So basically on ship we have the AC supply, but we have the rectifier unit. I will show you the sketch also in which it is being converted and supplied. So what happened? It is going to provide a continuous supply of electron to the anodes, and anode itself is a permanent anode. It's not going to be sacrificed, made either of titanium and in some cases platinum also. So please remember that the anodes, these are the permanent anodes which is fixed with the ship's hull and made up of titanium and platinum. So what happened? High input impedance voltmeter and suitably with the silver alloy sensors, this measure the electric potential to the hull. That is something which is the reference cell, or you can say the reference electrode, which measures the continuously measuring the hull potential as it is changing. When the vessel is going to from the seawater to dock water, seawater to fresh water, the speed, the draft will change, these things will change. So this is measuring the exact requirement of the ship's hull potential, and then accordingly the controller will adjust the supply of current to the permanent anodes. Being the self-adjusting, as we have seen in the previous slide, we can adjust itself to the deterioration of the hull coating also. So this is also one of the benefit. Like if the ship's hull is new, then the amount of current is required is not much. But as the ships is going to be older and older, then you have the breaking of the hull coatings, the corrosion will be more. So in that case, it will increase the electric consumption. Impressed current systems are to be switched off when divers are at work in around hull. This is the very important part. What happened? We have to switch off the electric supply when we are uh, berthing in the ports, as well as suppose we have the underwater hull examination or the divers are doing some maintenance. Then in that case also we have to switch it off for the safety part. Now in this diagram, I will explain you whatever I have told you guys. Like this is the working principle of the ICCP. Reference electrode is there. The main function of the reference electrode is to measure the required electric potential for the hull. And here this feedback is supplied to the control unit. And the control unit, what is the main function? It is going to supply the required potential difference to the main anode, which is basically insulated from the ship's hull. And what happened once the seawater is there outside all along area, means it is fully submerged, then it is going to do the action. It is going to make the complete ship's hull, complete wetted surface area of the ship electronegative. And here you have the cofferdam arrangement, and here is the power supply basically, which is going to do all the work. This is something which is the main anodes, permanent anodes, which is titanium or platinum, also seen. Sometimes it is lead silver also. And basically it consumes also, but it's very slow rate. The approximate lifetime is of 10 years. It is there attached with the ship's hull. It is not as a extra appendages. It is not going to create any of your drags. Okay, not much. So this is attached, and approximate life is 10 years. Here is the complete diagram of its impressed current cathodic protection system. So here you can see in the aft part also we have the anodes, and in the forward part also we have the anodes. This is something which is having the water line. So whatever the anode and the reference cell which is there, it is all under the water line. That is means it is deeply submerged. And here this is something which is your complete unit, controller unit. So here you can see from the ship's AC supply, the power is coming to that, the power supply is there. And as per the requirement, it is going to be supplied to all the nodes. So what happens here, we have the reference cell. This reference cell is going to measure, as I have explained to you in the previous slide, that this is going to measure the required electric potential, which is sent back to the controller. This controller has got feedback. It is also connected with the earth system, and the difference is being calculated, and this difference is being sent to the controller unit, rectifier unit. And here what is happening, the DC current is being going to be supplied to the anodes, and these anodes were supplying the current to the hull, or impressing the current to the ship's hull. So what happened, the ship's hull become completely electronegative, which is deeply submerged with the water, and this is getting protected from the corrosion part. Working of ICCP, as we have discussed earlier, the reference electrode measure the voltage difference between them and hull, and directly related to the amount of protection received by the hull. Controller will compare the voltage difference produced by the reference electrode in the internal voltage, and the output is automatically adjusted to maintain the electrode voltage equal to the preset voltage. Basically, it is changing, the requirement is changing, and controller is also giving the required difference, and it is sent to the. So power supply in response to the signal from the controller regulates the amount of shipboard alternating current. Yes. So basically now the reference electrode is the key part. It measures and the difference is being calculated, and the controller regulates the amount of required alternating current, and it sends to the rectifier. As I have shown you, there is a rectifier unit, and converts the regulated AC to direct current, which is impressed on the anode. An anode is mounted on the ship's hull with an insulated reinforced resin holder, which I have shown you earlier. And DC from the power supply is fed through the anode to the hull, and thus completing the complete electrolytic circuit, and function is. Now we are going to discuss more about on the reference cell potential. Reference cell potential is actually main part, and it is going to tell you what is the amount required for the supply to outer hull. So it is basically the electric potential of the outer hull, which is measured by the reference cell. One terminal of the display unit is connected directly to the hull. Another terminal is connected to the zinc electrode fixed to but insulated to the outer hull. When zinc and steel assembly is immersed in the electrolyte such as seawater, a galvanic potential is created. So without the immersement in the seawater, nothing is going to happen with ICCP. That's why in the dry dock, we are going to switch it off. So sometimes in the orals also, or in the exam also, it is being asked in the dry dock why the ICCP is the switched off. Because one is the safety part of it, and another is that it is of having no function because the seawater as an electrolyte is not available. The magnitude of the potential varies. So how hull potential varies. That is also very important point of consideration when we are discussing the ICCP part. So here you can see how it is measured, and it is basically measured directly. The amount is being sent to the computer and it varies according with such parameters. Number of first parameter, amount of exposed steel area, that is your wetted surface area. So if it is large, it is small, it is draft is more, draft is less. So this area will change and then accordingly requirement is changed. Which is next is your wetted vessel draft and condition of external coating. Yes, the coating means self-polishing paints which are there. So I will discuss and I will make one video on self-polishing paint also. So condition of the external coating is also matters. If it is perfectly new, the requirement is less, and if it is deteriorated, the requirement is more. Another one in continuation with this is your conductive properties of the electrolyte. I told you if it is seawater, if it is fresh water, then the things will be different. Okay. Next are some of the miscellaneous factors like composition of steel and at the molecular level. Next is your vessel speed. If it increases more, then turbulence is more, availability of oxygen is more, and it is going to have more corrosion. So vessel speed also matters. And this is also going to change the potential of the hull. pH of water, as we have seen, it is seawater, it is fresh water, and also this will also change. Temperature of water, you are going to sub-zero temperature, you are going to tropical climate, you are going in a hot climate. So accordingly, the temperature of seawater change, then this potential also change. And availability of oxygen as per the turbulence, like in forward and aft, the turbulence is more, availability of the dissolved oxygen is more. So we have to keep in mind all these factors which basically varies the potential of the heart, and accordingly the reference cell is going to measure it automatically, and after that it is going to give the feedback to the controller, and the controller will supply the required potential to the hull so that hull will maintain cathodic and it get protected. Some additional protection provided by the system which is there. Number one is you can see tail shaft and propeller grounding assembly. You must have noticed in the aft side of the engine room, the propeller shaft grounding assembly is there. Basically for the protection of the fittings in your main bearings. So basically whatever the current which is being generated, it is being grounded by that. So it is one of the additional part which I have shown you in the starting slides also. It feeds the protective current to the intermediate tail shaft and the propeller, in addition to safeguarding against the premature main bearings and the journal's failure. Basically, the protective current is being provided, it is being grounded. Okay. Another one is your rudder stock grounding assembly. It allows the protection to be provided to the rudder. So same with that, the rudder is also being getting protected, and the data logger of an IP logger intelligent system basically twice daily records this all data, the required reference currents, potentials, supplied currents, differences of all ICCP system readings to the ship's computer and saved and make the trend analysis. So in 1 month or 3 months, we can see the trend analysis part also. And the same time, this is being now all the ships are connected with the internet. So company, the data is sent to the company and the owner's office. Basically, when the current is increased, the hull corrosion rates decreases. We have seen. But if you supply extra current, more current than required, it is not going to give any additional benefit. Basically, we are losing the amount of the excessive current. And if it is more for more larger time, it is going to damage the hull protective coatings and the part. Okay. So this is of no use if we supply the excessive current. But when the current requirement increases, the hull corrosion rate also decreases. That is also the main factor you have to keep in mind. Thank you. I hope whatever I have discussed in these uh, two videos, like part one and this is part two, the corrosion and the types are being understood by you guys, and where it is found or located on board ship. And the third one is the preventive measures. So, in the next coming video, I will come back with your ICCP and sacrificial notes. Thank you.